All right, video number 3, lesson 3, Math 5130. I want you to go to StatCrunch. Of course, obviously, I'm in my stat lab. And I want you to go to data sets from your textbook. And I want you to scroll down to freshman 15. And this is an interesting data set because, first of all, when it's presented to us, if we read left to right, for example, let's just come down to case number 7. We can see that this person has listed female as their sex. Their weight in September is 64. That must be metric kilograms, I guess. Their weight in April is 60. Now, I really don't know whether that's whether April comes before September or September comes before April. So anyway, that would be important to know if you were really working with this. So also a BMI, September, because it looks like all the measurements are decreasing. And I don't think, well, whatever. All right, just stop. Okay, so I like this data set because it allows us to think about a data set like this as an independent samples t-test versus a dependent samples t-test, because we have multiple measures on the same person, right? We have a measurement in September, a weight, and in April, and then we have a BMI in September and a BMI in April. So we have kind of a repeated measure situation. Now, if I was going to run an independent samples t-test, what I may want to do is I may want to choose any of these quantitative variables and examine the mean difference over sex. But I really, really, really despise what we have to do in StatCrunch. Okay, so if I come to StatCrunch and I go to tstat and run a 2-sample with data, I have to have my samples in columns, which is really completely different than what I've told you that we need to do. In fact, it's in complete opposition to that. So I don't like that. But we have to work with StatCrunch as the features that it gives us. So what I need to do is I need to create a new data set where I have, let's just go with the BMI April, where I have one column of BMI April for M's and one column for BMI April for F's. It turns out it's really easy to do this. Just go to data, go to arrange, and go to split. So the column I want is BMI April, and I want to split by sex. And I want to open this in a new data table. And you can see now in one column I have BMIs for F April, BMIs for M April, and it completely contradicts what I've taught you so far in this class. But that's what we got to do, all right, to make it work. So now I can go to statistics, I can go to tstat, 2-sample with data. I can choose April in the first. Well, I'm sorry, I can choose female in the first and male in the second. So I'm testing that the differences of the means is equal to 0, and just hit compute. Now when I get this, let's talk about what each of these components actually means. So first of all, again, we're testing mu1 minus mu2. The sample mean difference is negative 1.12, standard error 0.89. The degrees of freedom are 52.48. Our test statistic is negative 1.26, and our p-value is greater than 0.05. So we would fail to reject the null and conclude that there's no difference in the population means. Now, when I run a confidence interval, just ask yourself, are you expecting this confidence interval to contain 0 or not? Well, we don't have statistical significance, so we're expecting the confidence interval to contain 0. So the lower limit is negative 2.91 up to 0.67. So this clearly contains 0. So it just reinforces, if you will, the decision made by the hypothesis test. Now, if I'm going to run a dependent samples t-test, and again, we're just kind of chipping away at this, right? We're going to get pretty serious in the next video. I mean, we're kind of serious right now, but so if I'm going to run a dependent samples t-test, what I may do is look at the difference from September to April. So now I have the data set in the form that I need, and I can easily run this using tstat, go down to paired. So my first measure is going to be BMI for September. My second is going to be BMI for April. And I can save the differences. I think that's actually a pretty good idea because it gives you a visual and a context. And then we're going to carry out the hypothesis test where the mean difference is equal to 0. So we're actually just testing to see of the difference from September to April, is that mean, population mean, different than 0? Again, based on sample data. So I hit select or I compute. Tunnel vision usually comes to the p-value. So let's walk across and talk about this. So the mean difference, if I take all the sample differences, 3.88 plus 2.26 plus 1.66 plus a negative, all these, and I'm going to divide by 67. I get a difference of the means. Standard error is 0.15, degrees of freedom 66. Remember, I don't think I've talked about this yet, but the degrees of freedom are always, for the dependent samples t-test, n-1. Our test statistic is negative 2.95, p-value statistically significant. So this would be significant at the 0.001, right? No, it would be significant at the 0.01 level, and that was covered in the last lesson. So we have statistical significance. We're seeing a difference in the mean of the differences for the BMI from September to April. Now, go to the confidence interval. Now, ask yourself, are we expecting the confidence interval to contain 0? Well, we have statistical significance at the 0.05 level. We're constructing a 95% confidence interval. So we do not expect, we expect our confidence interval to be all negative. And you can see it corresponds exactly like it should. Negative 0.76 to negative 0.15. So we're saying that there's a 0.95 probability that this interval contains the true mean of the differences in the BMIs from September to April. Now, something we can do that might help give you a little visual there. Let's go to summary stats column. Let's dive into some descriptives. And I'd like to look at the mean, and I'd like to look at the standard deviation. So you can see my mean for April is a little bit higher than the mean for September. So this is kind of making me believe that the September measurement came first and the April measurement came second. So 2022 to April 2023. So we're seeing an increase in the mean BMIs across those. And then we can see that our standard deviations are pretty similar. Okay, so we're going to get a really super technical in this next video, but I just wanted to show you how this is done. Actually, I take that back. The next video, I'm going to demonstrate this in R and and show you how those calculations are made, and then we'll get pretty super serious in video number 5. I think that's where the class really begins to start taking shape, if you will. All right, that's all I got. Take care.